Hello, today I would like to measure some stuff on my Tesla Coil. So this is the setup. We have the Tesla Coil with a light on top to see whether it's on, not the breadboard with the stereo exciter circuit on, and the blue vise in which I'm measuring the voltage, which is this channel in green. So I can sort of calculate the voltage on the top load of the Tesla Coil. In light blue we have the voltage at the power supply, and in dark blue we have the current going out of the power supply. Turn on the Tesla coil, the light turns on and the voltage goes up. If we do freeze and zoom in, we see that the voltage in the power supply is quite similar to the voltage in the vise, and the current, we can zoom in, and it's slightly phase shifted. So we can see this. We can see what happens if we do something like, for example, turn on a fluorescent tube nearby. We can see that the voltage drops and the current goes up. Voltage goes down. The blue tube has a similar effect. The voltage in the power supply seems relatively constant, even if the current changes. If we do an arc instead, we see that there's a much bigger effect. So the voltage changes a lot. So the voltage in the device drops a bit from 140 volts, and it reaches as low as about 40 volts. In the power supply, there is quite a high peak voltage, a very high peak voltage of up to 60 volts. I wonder why my capacitor hasn't blown up, since it's rated only for 35 volts. The current goes up to about 6 amps, which isn't that much. I would have expected more by the size of the arcs. That's okay. Since the voltage rises this much, we should see why it rises this much, and we should try to find a way to keep the voltage lower. Done the measurements I wanted. I'll stop the recording. Bye.